Okay, I've got a couple of questions on. Okay, I've got a question, what do I do with that thing? There's a piece of chalk sitting on it already. I'd have never found it under that piece of chalk. Same color as the chalk hides it completely. Okay, well, not really. Okay, so we have a problem here. We got linear function. F of 2 equals -4. Slope 3/8. How do you find the equation? Well, I'll ask, what's the first thing you do with that information? A, try to remember a formula. B, sketch it on a graph. How many would go with try to remember a formula? How many would sketch it on a graph? I think trying to remember formula is not the way to go. Trying to remember formula doesn't show you anything. Now, if that's the way you want to do it, okay, then you better memorize about 50 formulas. Okay? And you want to memorize 50 formulas? Or can you just learn to sketch graphs and let that guide you? Now, knowing formulas is good, but formulas, if you don't remember them, in the first place, you're dead in the water when you come to a problem, right? And in the second place, you never really understand the formula. Okay, so you never really understand the mathematics as well. Now, you should understand both. But I think the thing I've always stressed through this course is graphs. You start with the graph and you do everything you can with the graph, and then you get it. So how can you put the information that you have here on a graph? Okay, so, somebody said, you got Y, something about Y. I said, well, what about Y? And so I said, well, -4. All right. Of course, I would ask, what's F of 2 equals -4 tell you? And Y is -4 and X is 2. So this is because we graph Y equals F of F. Every time you see a graph, it defines Y equals F of X. You see me write that 1,000 times. Your book has probably said it 1,000 times, okay? And you know that, everybody pretty much told me, you just weren't real certain about it. Well, something you really want to be certain about, okay? That's really foundational for understanding anything like that. Okay, so if Y equals F of X and Y equals -4 with X equals 2, well, we can draw a point, and we don't need to line off a graph. We don't need to spend 3 or 4 minutes marking the graph off. Okay, we just say, okay, I'm going to put 2 here. And I'm going to put -4 here. Everything else follows from that. Once you have the point where X equals 2 and Y equals -4, you can mark off the rest of the graph if you need to, but you don't need to in this case, because you're not going to use your graph to like find your intercepts or anything. You can estimate. Okay, well, what does the slope of 3/8 mean? How can you represent that on the graph? Okay, so the other bit of information we have is the slope. What are you going to do with the slope? How are you going to use that? Well, it's rise over run. Somebody told me rise over, right? So what rise would you use? What use the rise of 3 and a run of 8. And I think I said something completely wrong a minute ago.
Okay,
But we're gonna do it, okay? So we're gonna have a rise of 3, that would take us up 3 units, when I put -4, that would take us to -1, right? And a run of 8 units would take us out to 10. So got 8 here and 3 here, now we've got 2 points on the graph. So we got options as to how we would do it. Now, I would not bother using 2 points, but since we have 2 points, it can illustrate 2 ways we could get this equation. And one way is, and we know function is linear, so y equals mx plus b. And we know that y equals -4 when x equals 2. Okay. Actually, we have the point 2, -4. This tells us that -4 equals m times 2 plus b. Now we even know more. What else do we know about this equation? What other numbers could we put in? I think everybody knew the answer. Somebody said right away, use 3/8. Well, yeah, the slope is 3/8, so we can plug in for 3/8. Get -4 equals 3/8 times 2 plus b. Now, when we had it in this form, we couldn't solve for the 2 quantities that we didn't have a number for, okay, for the 2 unknowns, but one of the unknowns wasn't unknown, but so we plug in, we given information, and now we've only got 1 unknown and we can solve for it. Okay, so we multiply both sides by 8. And I'm not going to take the time to do all the detail how we do this. But if we multiply 3/8 by 8, we're going to get 3. If we multiply that by 2, we're going to get 6. Now, one way or another, you got to know fractions well enough that that's a simple, straightforward thing, and you're not going to make a mistake on it. And not understanding how to do fractions, something that people tend to be very weak on when they come into the course, and not awful strong on at the end of the course. That's a tendency. So everybody does pretty well with fractions, but you want to be solid on that, and everybody could get a little more solid. Okay, so anyhow, this leads to 8b equals -38, so that b is -38 over 8, which reduces to -19/4. Now, -19/4 is close to -5, right? Let's look at the graph. Does it make sense that if we have these 2 points, that the y-intercept would be -19/4? Because of course b is your y-intercept. If x equals 0, y equals b. And we have to know what an intercept is. Okay, y-intercept is where x equals 0, x-intercept is where y equals 0. Okay, those are just fundamental things that we have to be sure we understand. Okay, so we get b equals -19/4. So now we have the equation. And there we have it. But we could also let let y equal 0 and solve for x. And we get x equals negative 38 over 3. Okay, well, that's between negative 12 and between 12. That would be wouldn't be negative, it'd be 38 over 3, be between 12 and 13. Now, out here, this point is 10 negative 1. Does it make sense that the x-intercept would be out around 12? Well, from here to here is 10. That looks like it's 2 or 3 more, doesn't it? At least reasonably. So if we solve for the y-intercept, we can get that. All right. Now, let's find the equation using these 2 points. But so far, everything holds together, and the graph holds it together. We're not just doing symbol manipulation. We have a meaning here. Everything has a meaning. And if you can comprehend that meaning, then you're really learning the mathematics. If you can comprehend the meaning and do the algebra and the arithmetic, okay, that's when you really understand something. And you want to strive for the deepest understanding you can achieve in this course and in future courses. Okay, so now we can use the fact that we have 2 points. Okay. We weren't given the point 10 negative 1, but we can certainly get it by using the run and the rise. And the point that we do know. And now, one way to do that, use a fundamental triangle and find the slope. Okay, so fundamental triangle. Rise is I'm writing it's a numerator. Because I'm thinking about the fraction, but that's why. I don't know what. Okay, rise is -1 minus -4 equals 3. Now, of course, we already know what the slope is. But if we had 2 points, just to illustrate what we do when we have 2 points, you got 2 points, let's say use a fundamental triangle. Okay. So here's our fundamental triangle. So we would label this because it's really handy to know how to do this. And the slope is then get the arithmetic right, I'll have this. Run is 10 minus 2 equals 8. And the rise is -1 minus -4 equals 3. So the slope is rise over rise is 3/8. I'm giving you an algorithm for doing this. I recommend it because again, it makes sense out of things, makes visual sense, but you're going to remember better and you're going to remember formulas. Okay, and how the slope is 3/8, and now that you know the slope is 3/8, you can use the point 10, -1. Equals 3/8 times 10 plus b. Multiply both sides by 8. Get -8 equals 30. Plus 8b. And so here's the wrong here. This gives me it's all work out. Let me stop the video for a second, see what bonehead thing I'm doing here. In my mind, take a vacation there. This is right. So B is -38 over 8, which is -19/4. And now we see this agrees with this. We get exactly the same thing. We have a slope of 3/8 and a y-intercept of -19/4. So if we had the 2 points, we would reason it out like so. Now, one of the easier formulas to remember is y minus y1 equals n times x minus n1. Okay, remember that formula, you could also use it. It's easier to connect this picture to the equation if you know how to do this than it is to use that formula, but it's fine to use. Or we can also use y minus y1 equals m times x minus x1. You know, x1 would be a given value 2, and y1 would be -4. Now you can plug that in, it comes out very straightforward. It gets you the answer without any thinking. Except remember the formula. But if you're not visualizing what's going on in the graph, you might still miss what's in the formula, because the one thing that took people a little while is interpreting what f2 was -4. Okay. Once you see that that's the point of the graph, once you interpret the slope, then you have at least 3 ways to solve this problem. You have an x1 and a y1 if you want to use this formula. Okay. Or you can just say, okay, it's linear, so we have this. We just substitute what we know, and we end up with an equation for b. We already know m. We'll go on. You want to try to understand as much of that as possible because it's really fundamental. Okay, this is the velocity of this diver. This is something that you get. You learn how to derive this based on the assumption that the force of resistance of the skydiver is proportional to his or her velocity or speed. Okay, that leads to what's called a differential equation that's fairly easy to solve. And this is the solution. So differential equations is a ways from this course. Okay. Half the differential equations is pre-calculus 2, then calculus 1 and 2. Then you get to take either differential equations or monoverbal calculus. You take them both in the same year, okay, or at least consecutively. Right now, we're off the differential equations first. It's within better. Yeah, it's 6 1/2 dozen of them have done it both ways. Right now, I'm teaching monoverbal calculus. You people like Jason's differential equations course in the fall. I'm still around when you get to those courses. Probably have me for one of them, basically for the other. Unless Will decides he wants to throw his hand in there. Okay. Okay, so anyhow, that just gives you an idea of things are headed mathematically. If you do the engineering curriculum, now if you're going to do business or pretty much anything else that people usually take, unless if you're going to major in mathematics, you're going to major in physics, and take those courses for sure. But other than that, people are going to do that, so I'm going to stop talking about it and just solve this problem. Okay. So this is the velocity of this skydiving. What's the velocity after 2 seconds? Well, plug in 2 seconds. Time is measured in seconds here. Velocity is measured in, I don't know what is it. It's you say what have you? It's in meters per second. The terminal velocity is close to 200 miles an hour. It's miles an hour. Terminal velocity is 80 miles an hour. It's feet per second. That's way too low. So I don't know what in the world they're thinking about with this example. That's not very realistic unless you got a really weird shaped skydiver. Okay, or you got an average skydiver holding a big old cannonball. Then that could be a meters per second. Anyhow, whatever it is. Kilometers per hour, we're using. Okay, well, all that aside, I don't think it's a very good model, but you got to randomize the numbers. Okay, so that's where the numbers came out. I'm criticizing the person that made out this practice test, really good practice test. Okay, so anyhow, V of 2 is going to then be 80 times 1 minus e to negative 0.2 times 2, which is 80 times 1 minus e to the negative 0.4. And you really ought to be able to graph this function, but not really. It takes a little more than just plain old transformation. Any case, and this should be 80, not 8. E to the negative 0.4. Okay. Well, I can estimate e to the negative 0.4 because I can sketch a graph. And even if you have your calculator in hand and get the answer by punching it in, especially in a practice test, you want to think, what's this look like? Okay, so this would be 1. And when you get out to 1, he's down to about e to the negative t is down to about 0.37. Okay, but e to the negative 0.4, well, 0.4 would be about here. I'm going to say that's about 0.7. So we're getting 24. that what it is? Okay. 25? Okay, so if I'd estimated this to 7 or 8 more decimal places. I don't know. They think being able to draw these graphs and use them is very powerful. Okay, if you're thinking about this thing, yeah, you can plug the numbers in, but you don't get the pictures. Okay. So you understand more, but in this case, I pretty much expect people just plug this in and punch some buttons. Okay, that's okay. This is an enhancement. Okay. Yeah, apparently I nailed it critical. It should be 25, but that was just my mark. Not very well drawn graph. I don't even know if it's got a consistent half-life. It looked pretty. But that doesn't mean that. Okay, well. So B of 2 is approximately 24, turns out to be 25. Now, the other question is, when will the velocity be 70? And they say this is in feet per second. That's pretty ridiculous. Anyhow. And it's so ridiculous, I forgot to know, but I could be about even one. Okay. Nice and literate. When velocity is 70. What is the velocity 70? Okay, well, what would you do with that? Anybody have a suggestion? Okay, I think it's kind of important for application to understand how to construct graph of this function, but it's a really hard sell. Get people to do that and understand it. So that's the way it looks. And conceptually, you ought to kind of understand that. Okay, well, here's D, and here's P, and here's A. Velocity approaches 80, asymptotically. Not too hard to understand. You can jump out of a few airplanes, you get the idea. Okay, well, you want to know when the velocity is 70, right? So that's kind of a picture of what you've got and what you're at. Okay, let me insert a little bit more here. Basically, the do is what's on the end. Okay. Here's your velocity. So let the velocity be 70. So we write 70 equals 80 times 1 minus e to the negative 0.2. Now we can solve this equation. It's good for we can solve the T. Well, let's go ahead and solve it. Various ways I could solve this. I could distribute that 80 through this expression. Okay, or I could divide both sides by 80. I'm going to choose to divide both sides by 80. Okay. I mean, if you just distributed here, then you had another obvious step. What you're trying to do is you're trying to isolate this t, and you know you're going to have to use a logarithm because he's in the exponent. Well, we do a little more rearrangement, so we get (70/80) minus 1 is negative e to the negative 0.22. 70/80 minus 1 is, well, that's 7/8 minus 1 equals 7/8 minus 8/8 equals negative 1/8. Now, if you visualize 7/8 on the number line, you divide the interval from 0 to 1 into 8 pieces. But you know how to read a ruler. Okay? Or a tape measure. It's pretty clear that if you subtract 1 from 7/8, well, you're going to get a negative 1/8. So this is negative e to the negative 0.2t equals negative 1/8. So the e to the negative 0.2t equals 1/8. So log base e of 1/8 equals negative 0.2t. And of course, that's a natural log. So you get t equals negative natural log of 1/8 divided by negative 0.2. And now those steps ought to be kind of obvious. There's how you solve it. We convert from exponential to logarithmic notation. And we just divide both sides by negative 0.2, and we've got t. I use ln there instead of log base e because that's what log base e is. That's the button on your calculator that you're going to use to evaluate this. And at this point, you just punch it in your calculator, punch it carefully. Okay, I think we're a little bit out of focus again. Okay, we got this. Okay, we got y equals x squared minus 12x plus the quadratic formula. Tells us what? Okay. So what's everything that the quadratic formula tells us? I'll let you think about that for a couple of minutes while I run over and pick up the practice tests. Okay, so what's the quadratic formula tell us? It tells us we can work the quadratic formula. Everybody can work the quadratic formula. You might work it accurately, you might work it inaccurately, but if you're careful, you can work it. And if it gives you sensible results, it's fun. Quadratic formula tells us X values that make y 0. Because the quadratic formula gives us a solution to a quadratic equals 0. So we really have to understand that about the quadratic formula, what it's telling us. Okay. Now, gives us the intercepts. If any, and parentheses around the s on intercepts because it could be just one. You can have a parabola that just sits right on the x-axis, the vertex is on the x-axis, that would just be 1, 0, right? 1 point on the x-axis. It could be above the x-axis, opening upward. It could be below the x-axis, opening downward. And there'd be no zeros. Or it could have 2 zeros, okay? That's important information. It also tells us the axis of symmetry. Here is all you're going to need for open math is formula. And remember another rule, the axis of symmetry. That's fine if you want to memorize 2 formulas, but as we've said, and sketched out multiple times. So hopefully you're ready to really lock it in. This is the way I write the quadratic formula. Okay, so the answer is the thing that I've done here that isn't in the way you usually write the quadratic formulas. I circled this negative b over 2a. And of course, you should recognize that as the formula for the axis of symmetry. Okay. But what I told you about that. Okay. This has to be halfway between the zeros because negative b is halfway between negative b plus the square root and negative b minus the square root. If you lock that in, you have a very simple picture of the way you proceed to graph your quadratic. Okay, so this 5.6 is your axis of symmetry. That's, in some sense, where you want to start. So you sketch your axis of symmetry. Okay. Once we know the axis of symmetry, we plug in x equals 6 and find the point on the graph that lies on that axis. The vertex is on the axis of symmetry. Well, that's gonna be at the y coordinate you get when you plug in the axis of symmetry. And that's gonna be 3666 minus 72. If I did this correctly, it turns out to be a point is -6. There's a point on our graph. I mean, even if I got the axis of symmetry wrong, if I plug in correctly, I'm going to get a point on the graph. Okay, well, what's the next thing we do? Get y equals 30. X is 0, y is 30. So now I've kind of shot myself in the foot because if this is 6, 30 is up about here. So maybe we sketch another graph. X equals 6, we're going to put the point 0 to 30 here, then -6. 6 is 1/5 of 30, you know, so 1/5 of that distance, well, there's half, so about here. So here's our vertex. It's 6. -6, we found that here. We have the point 0 to 30. So now we can sketch a parabola. That'll be most nice. My attempts are still, the vertex is not quite where it ought to be, but there it is, okay? Now it looks like our x-intercept maybe at 0,4 or 0,3. I'm sorry, at 3,0 or 4,0, somewhere around there. You know, 2 or 3 units to the left of the x-axis of the axis of symmetry. 2 or 3 units to the right of the axis of symmetry. Well, we can figure out the x-intercept. Okay. Now you can get 14. 4 times 30 is 120. 12 squared is 144. And it's not 14, it's 24. Okay. Okay, we get 6 plus or minus 2.45, if I did that right. And that kind of validates my graph. I said it'd be 2-3 units to the left, 2-3 units to the right, well, it's 2.5 units. Real close to 2.5 units left and right of the vertex. Okay. And that's going to be then 8.45 or 3.55. So our x-intercepts would be 2.550 and about 8.450. That's a complete picture of how you can sketch the graph of a quadratic. It also tells you, I don't have time to do this for the other time, but this tells you that this function could also be written as y equals x minus 6 squared minus 6 at the vertex point. Something you might or might not need to know if you're in my class, you should know that.